So in this video we will understand how to determine the empirical formula. So one can determine the empirical formula from the percentage composition by three ways, and if we know the mass percent of element, then we can assume that in any formula the total number of element will be 100% or 100 gram, and then if we know the gram of each element, then use molar mass to find out the mole of each element and then calculate the ratio. So this is the simple pathway to determine the empirical formula. First you have to find out the mass percentage of element, then assume 100 gram of sample, then convert gram of each element, use molar mass, find out the moles of each element and calculate the molar ratio, find out the empirical formula. So there are three methods to use the find out the empirical formula. Number one is if we have information of given the gram of each element present in the compound, if we know the gram amount of each element in a compound, and given the percentage composition of each element present in the compound, if we know the gram quantity, if we know the percent composition, or if we know the combustion analysis data of the compound. So there are three methods by which we can find out the empirical formula. However, in earlier slides or videos we have seen the empirical formula is the formula of any molecule which is shows the whole number of, like the simplest formula. For an example, C6H12O6 is the molecular formula of glucose, and if I divide the whole glucose by 6, so then we will get its empirical formula CH2O. So this is the one way to find out the empirical formula, but it is not easy to find every time using this method. So we have to use either gram quantities of element or percentage composition or combustion analysis. So let's see the first example. Determining the empirical formula. For an example, the compound para-aminobenzoic acid. You may have seen it's limited as a PABA on your bottle of sunscreen. So this compound is used on the sunscreen. Is composed of carbon 61.31% and hydrogen 5.14%, nitrogen 10.21%, and oxygen 23.33%. Find the empirical formula of PABA. So this shows that it has carbon, it has hydrogen, it has nitrogen, and it has oxygen, but we don't know the subscript right now. We have to find out the subscript to get the empirical formula of PABA using the percentage of each element. So how we will find out the using percentage to find out the subscript? Let's see. So assuming 100 gram of PABA or para-aminobenzoic acid and converting to mole. So in the question they have given that carbon is 61.3% and hydrogen is 5.14%. so we are assuming that they are total 100 gram, and just I'm taking these percentage as a gram. So I will convert gram into mole. So if you remember this simple rule we have seen, first we have to convert all the percentage. Assume 100 gram of sample, convert grams into mole. So we will convert percentage of carbon as a gram quantity, 61.31 gram, multiplied by 1 mole, and carbon has 1 mole of the weight is 12.01 gram. Then what will happen, gram will be cancel out, then you have to divide 61.31 by 12.01 and the calculation will come 5.105 mole of carbon we will find out, we will get it. Similar way we have to find out how many moles of hydrogen are in 5.14 gram. So 1 mole divided by the molar mass of hydrogen is 1 gram, so it would be almost same. For nitrogen, 10.21 multiplied by molar mass 1 mole divided by 14 gram, and then this number comes 0.7288 mole of nitrogen. And same way we have to find out how many moles will be in 23.33 gram. So we just convert percentage into gram, and now assuming that all these percentage when we will add it, they will become 100%, and we have a sample of 100%. So once we will know that how much moles are there, then we have to find out the molar ratio. And how we will find out the mole ratio of each element? So what we have to do, you can see we have to divide each mole by the minimum number of mole. So out of the carbon, hydrogen, nitrogen and oxygen, the minimum number of moles are for the nitrogen, which is 0.7288. so we have to divide every other element mole by this number. So here we divided carbon mole by nitrogen mole, and then will come around 7. Hydrogen mole divided by nitrogen mole will come around 6.9. We can make it average as 7 again. Nitrogen mole divided by nitrogen mole will give you 1, and then oxygen mole divided by nitrogen mole will give you around 2. So now we know the ratio of each mole is 2 oxygen, 1 nitrogen, 7 hydrogen and 7 carbon. So now we can figure it out what to write the subscript on the power formula. So carbon would be 7, hydrogen would be 7, nitrogen would be 1, so we don't write 1, and then oxygen will be 2. So this is the way you can find out the simple version of empirical formula using percentage. So if we know the percentage of any element, we have to convert into gram, and gram quantities will be converted into number of moles, and then moles will be divided by minimum number of moles to find out the ratio of each element in the molar quantities. So this was about the empirical formula. Let's see one more question here. One more question is A 100 gram of sample of a white powder is analyzed to find contain 43.64 gram of phosphorus. So here is the phosphorus, which is 43.64 gram, and 56.36 gram of oxygen in the mass. What is the empirical formula of the compound? So look like they are talking about the phosphorus and oxygen. The compound will contain only phosphorus and oxygen, but we don't know what should I write the subscript here as a empirical formula. So but we know the gram quantities of each element, so we have to convert gram quantities into moles, and then number of moles will be divided by. So let's see this how to solve this question. So first we will, so phosphorus and oxygen are given quantities is 43.64 and 56.26 gram, and if we will add these two, this will be 100 gram exactly. So you can say that 43.64% of phosphorus is there and 56.36% of oxygen is there. So first we have to excuse me, we have to convert gram quantities into number of moles. So how we will convert? Basically, grams, and phosphorus has a molecular mass is 30.74 gram, so we will divide by 30, we will get 1.4 1.4 mole of phosphorus. Same way we have to find out the percentage of number of moles of oxygen, which is gram quantity of 56.36 gram, and then 1 mole using this conversion of oxygen molar mass, which is 16. So once we will use 16 to divide 56.36, it will come around 3.5 mole oxygen. So now we have the mole quantities of 1.4 mole of phosphorus and 3.5 mole of oxygen. So which is the minimum here? So the minimum is phosphorus 1.4 mole. So we'll use this number to divide both of the element. So here we divided this phosphorus 1.4 mole divided by 1.4 mole, so this will come 1, and then oxygen mole will be divided by phosphorus mole, so 3.5 divided by 1.4, which will be around 2.5. So now we find the mole ratio will be like a phosphorus and oxygen will be 1 and 2.5. So we can also write like this: phosphorus 1 and oxygen will be 2.5. But in empirical formula we never write in any element in the fraction, so we have to multiply these number in some quantity so that we can get the whole number. So easiest way to multiply these number by 2, then this will become phosphorus 2 and 2.5 multiplied by 2 will become 5. So this would be the empirical formula of P2O5 for this question, where is said that 100 gram of white powder. So white powder is a P2O5. White powder is P2O5. And how we find out? We use this gram quantities to convert mole, and then mole ratio, and then find out the whole number of the moles. So these were the example to find out the empirical formula using grams quantities or percentage quantities?